This video is on solving one-step linear equations. We covered what a linear equation is in our last video, so hopefully you will understand that. This video just focuses on one-step equations. And the first skill that you need to have is to be able to solve an equation by inspection. And by inspection just means to look at an equation and know what the solution is. So these are relatively straightforward equations. So the first equation I've got here says x plus a number called 3. So I don't know what x is, but I know that if I add 3 to this number, I'll get 10. Hopefully you can think of a number that if I add 3 to it, I get 10. And that number is 7. So it means that if I replace this x with 7, 7 plus 3 does equal the other side. So that's very important with equations, that you can see that whatever the solution is, when you replace the variable or the pronumeral with that solution, then the two sides of the equation, so this side here, the left-hand side, and the right-hand side should be balanced. What I want you to do now is pause this video and try and solve the remaining 3 equations by inspection, and then unpause the video and we will go through the answers. All right, let's go through the answers. So this next equation says 5 times some number equals 20. I hope you know that 5 multiplied by the number 4 gives you 20. This one says a number divided by 3 will give you 6. I can think of a number that I divide by 3, and that is 18. And this equation says a number, take away 12 gives me 2. Well, if I start off with the number 14 and take away 12, I do get 2. So every time I write that solution on top of the pronumeral, I can see that my equations are working. And when I say working, it means that the left-hand side of the equation does equal the right-hand side. If it turns out that when you replace your number back into the equation, if the left-hand side doesn't equal the right-hand side, your solution is incorrect. So where are we moving next? Well, what if I can't solve an equation by inspection? What if I give you a hard equation like 0.4x equals 4, and you think to yourself, well, I don't know what I multiply 0.4 by to get 4, then you might need another method, and that would be using inverse operations. So inverse operations are operations that undo one another, and they're basically opposite operations. So sometimes you'll hear people referring to inverse operations also as opposite operations. For example, adding 4 and taking away 4, they cancel each other out. And multiplying by 5 and dividing by 5, they cancel each other out. So the opposite of adding would be to take away. The opposite of taking away or subtracting would be to add. The inverse operation of multiplication is division, and the inverse operation of division then must be multiplication. So how are we going to use these inverse operations? Here are 4 equations, and we are going to use inverse operations to solve them. So I want you to think of equations as a scale. And if you look at the two sides of your equation, they are balanced. And how do I know they are balanced? Well, I have an equal to sign that says that the left-hand side is equal to the right-hand side. So when you apply an inverse operation to one side of your equation, you must do it to the other side. So if you look at this equation, my goal in every equation is to end up just with this pronumeral. Okay, so I want to solve for the pronumeral. That means finding the letter. So here I've got this operation of adding 3. Well, the inverse operation is to take away 3, and whatever I do to one side, I must do to the other to keep the sides balanced. If you decide that you'll take away 3 from one side, but you don't do it from the other, then the equation is no longer balanced and your solution will be incorrect. So don't forget, whatever you do to one side, you must do to the other. And yes, you will show your inverse operations. So what you can see here is that the 3 take away 3, well, that equals 0. So I don't need to write anything there. You can put a single line through them, just a single line. And then that leaves me with the x. And then on the right-hand side, I've got 11 minus 3, and that is 8. So I know this is an easy equation to solve, but you can use inverse operations for much harder equations, for example, this one here and also this one over here. So let's try it again. Here I've got the operation of dividing by 1.5, and the opposite of dividing by 1.5 would be to multiply by 1.5. Don't forget inverse operations, and whatever you do to one side, you will do to the other. So I'm now going to multiply by 1.5. And if I have 1.5 in the numerator and a 1.5 in the denominator, well, they will cancel to give me 1, because 1.5 divided by 1.5 is 1. Any number divided by itself is 1. So I'll put a single line through those because I don't need to write 1 anymore. I'll just write down g, which is the same as 1g, but I don't need that 1. And then on the right-hand side, 10 times 1.5. Hopefully you know that when we multiply by 10, we can move the decimal place 1 over. So it'll move from here over to here, and that will give me that g is 15. Now here, in equation number 3, an easier way to write this would probably be minus 2/3 multiplied by a equals 8. So the opposite operation of multiplying by negative 2/3 would be to divide by negative 2/3. Now this is a question that a lot of students will get wrong or get confused by. When you do inverse operations, you are reversing the operation. So the opposite of multiplying is to divide, but nothing else changes. So the divide by minus 2/3 is exactly the same on the top and the bottom. You do not lose the negative sign. So the opposite of multiplying by 2/3 would be to divide by 2/3. That's why I've done that on both sides. So then, like we said before, any number divided by itself, so I've got minus 2/3 divided by minus 2/3, that will give 1. You can check on your calculator, but that means that minus 2/3 will go into itself exactly 1 time. And then if we go back to year 7 fractions, if I want to do 8 divided by minus 2/3, that would be exactly the same as 8 divided by minus 2/3 would be the same as 8 multiplied by minus 3 on 2. And then I can multiply that through. So I could either cancel the 2 into the 8 4 times, and then 4 times minus 3 is minus 12. Or if I wanted to, I could even multiply 8 by minus 3, which gives me minus 24, and then divide by 2, and I will still get minus 12. So my solution here is A equals minus 12. Last question. I want to get the n by itself. So I've got to do an inverse operation here of this subtract 10. So the opposite of subtracting 10 would be to add 10. Because I want to keep my equation balanced, I will add it to both sides. I know that minus 10 plus 10 will give me 0. So a single line through that. And I know that now I'm left with n. And on this side, minus 22 plus 10, the right-hand side, minus 22 plus 10 is minus 12. If you decide that you want to check your solution, which you really should be doing, don't forget, you can just replace the pronumeral with whatever your solution is. Let's check it. Minus 12 minus 10 is minus 12 minus 10 minus 22? Yes, it is. So that means this solution must be correct.